Good morning, students. Welcome into the another session of CS22 operating system concepts using Linux and Unix. As all of you know that we are discussing about unit number 3, that is process management. Lots many topic we have discussed in our previous lectures. I am not going to repeat all that points because it's already there in my previous recorded lecture. Let's start with the new concept that is called as segmentation. Segmentation is related with the memory management and the pagination. One word I would like to correct, that we are discussing about memory management, that is unit number 3, not a process management. That is my mistake. So in memory management we are discussing about the memory and its concept called paging. As we know that paging is a technique in which it allocates equal number of slots for number of processes which have unique internal ID, which is managed by memory management block to retrieve the information fastly for the central processing unit. This paging contains page number, page frame, and paging blocks. Based on this, the another technique which we can consider is called as segmentation. So the definition of segmentation is a memory management technique in which each job is divided into the several segments of different size, where one of each module contains equal number of pieces which performs a specific function, where each segment contains different logical space of a different program. This is the introductory part of segmentation. I would like to repeat my word. First of all, segmentation is a one type of memory management technique where a single job or a multiple job are divided into the equal number of segments which have a different size. Obviously here the size means the memory size, memory occupancy size, which contains different types of related functions. All these segments contain different logical space for a specific program. Now when the process is going to be executed, its corresponding segmentation, that means the process is a one job which is divided into the particular segment. Whenever that process is executed, ultimately that particular corresponding segmentation is also executed, so that corresponding segmentations are loaded into the non-contiguous memory through every segment is loaded into the contiguous block of available memory. So in segmentation there is a consideration of two different types of memory allocation, that is contiguous memory allocation and non-contiguous memory allocation. Initially, segmentation used non-contiguous memory allocation, but it is passed via the concept of contiguous memory allocation, which is available into the main memory, which is also called as primary memory, or we can say random access memory. Now, segmentation memory management works are very similar to the pagination. That means if we compare the segmentation and its theory with the pagination, it almost looks like a same thing, but there is a very minor change in between the pagination and segmentation is there. So that difference is mentioned over here. The difference is the variable length of pagination and the variable length of segmentation are different. That means in pagination, variable length are of fixed size, while into the segmentation, variable length are of varying length. Let me again repeat the word. Segmentation and pagination almost looks like a same thing, but there is a one minor internal difference is there. In segmentation, the assigned length of the space is different, while in pagination, the size of assigned space is fixed. So pagination works on fixed size, while segmentation works on variable size. That we can consider as a difference. Now, a program segment contains the program main function, utility function. That means whenever any job is executed, whenever any program is executed, it contains main parts like main function, utility function, data structure, memory allocation, etc. etc. The operating system maintains our segmentation map table for every process, which lists the free memory block along with the segment members, their size and corresponding memory location into the main memory. That means whenever the segmentation is maintained by the operating system internally also maintains a one table. That table is called a segmentation map table, in which there is a detailed information is stored which is corresponding to the memory location into the main memory. Now, for each segment, the table stores the starting address of the segment and the length of segment. A reference to a memory location includes a value that identifies the segment and its offset. Let me again repeat my words. During the management of segmentation by the operating system, that segmentation is maintained through a one internal logical table, that is called as segmented map table, in which it contains all the detail about segmentation, which is segmented value which is generated by the memory management block and assigned to the specific process or the block of process. In this table, each segments, the table stores the starting address of a particular segment and the length of that particular segment. That means The table which is maintained by the operating system contains the two different things, that is the starting address and the length of a particular segment. This is one of the example of a segmented table which is maintained by the operating system in between the allocation of memory for a specific process or the number of process. As you can see that on left hand side there are various segments are available, like segment number 1 is a one length or the one size of block, segment 2 is bigger in a size, segment 3 is smaller than 1 and 2, and segment n is equivalent to segment number 3. Here just observe the block which is created for the specific number of process or the processes. Now before allocating all these segments into the main memory, let me again repeat the word, before allocating all these segments into the main memory, in between these two, one table is maintained by the operating system that is called as segment map table, which we have just discussed. This table contains mainly the two things. Serial number is common one. Apart from serial number, first is the size and second is the memory address. That means this segment number 1 requires 400 bytes from the main memory to occupy all its process or for the specific single process. And the address which is given by the memory is 100. So this 100 is mentioned over here. This is the address of memory. Now for segment number 2, it requires 200 megabytes, 200 bytes. Memory has given the address number called 500. For segment number 3, it contains size called 100. The memory address which is given by the main memory is 800, and same like for the n number of processes. So whenever the process blocks are created and stored as a single segment which is of varying size, before storing all these segments into the main memory, the size and the memory address is going to be stored inside the one table that is called as segmented table. That theory I have mentioned in format of one graph over here. So this was all about the discussion of unit number 3 called memory management. Let's open the syllabus first and compare all the topics that we have done or not. So the syllabus is over here, and the code of our subject is CS 22. Just go into the unit number 3 called memory management. In memory management, first we have discussed about physical memory and the virtual memory. Then we have discussed about memory allocation function. Then we have discussed about contiguous memory allocation and non-contiguous memory allocation. Then we have go for then we have discussed about the technique called pagination, and in this lecture we have discussed about the technique of segmentation. So this pagination and segmentation is actually used to manage the virtual memory of the system. So all the topics as per the prescribed syllabus of Saurashtra University in these subjects for unit number 3 is covered. Now, unit number 1, unit number 2 and unit number 3, all these unit with their topic give us the idea of operating system, that how it handles the internal processes. All these are the theories that we have discussed, which demonstrate how the internal system works into the operating system. Now, in unit number 4, we'll get something new. The title of unit number 4, just focus on that particular title. The title of unit number 4 is Getting Started with Unix. So, we can say that from this unit, we'll get an actual idea of operating system called Unix. The title of our subject is Operating System Concepts Using Unix and Linux. So the introduction of Unix came over here in unit number 4. So without wasting more time for unit number 4, for the discussion of topic, let's start with topic number 1, that is called as Unix architecture. This is very important for university examination point of view. Question may be asked like this: write a short note on Unix architecture, or the question might be like this: draw and explain Unix architecture in detail. Before discussing in detail about the Unix architecture, this is the diagram of Unix architecture which we have to consider. It looks like a one spindle, where outer layer contains the application program, then inner core contains some words like base, more, pg, which, env, cut, ed, vi, shell, as, comp, cpp, sh, chs, ksh. All these are the Unix command. So internal core contains various types of Unix command. Be clear, here I have just mentioned few of the commands. There are thousands of commands are there which is stored inside the second core part. Then the third core part is kernel, which maintains the interface between the application program, various Unix command, and the innermost core is the hardware. That means kernel is the core person who maintains the communication between the various commands, obviously Unix commands. Now whenever I speak command means Unix command. It makes the communication between the hardware and various command and the application program, because the entire operating system works on request and response manner. Whenever any request came from application program, hardware gives the response, and vice versa. Whenever any response is generated by the inner core, it should be reached up to the specific layer. Either it might be a layer of commands, or either it might be the layer of various application programs. So let's start with unit number 4, that is called as Introduction to Unix Architecture. So first I would like to say something about the Unix. The Unix is an operating system which is a set of program that act as a link between the computer and the user. Actually, this is the general definition of operating system, not a specific definition of Unix. All operating system works like this. That means whenever we install any operating system, it is actually the interface in between the user and computer system. Why? Because the language of computer system is different than the language of user. Computer understands the language of binary, that is called as 0 and 1, while user have their own language. So to interpret the request and response in between the user and computer, one logical block of information executes in between these two entities, that is called as operating system. Let's go ahead. The computer program that allocates the system resources and coordinates the detail of computer internals with all that programs and allocated resources are called as kernel. If you remember, then I have shared one thing with all of you. To communicate between the two upper layers and the innermost layer, that is called as hardware, there is a one block. That block is called as kernel, which interprets, or we can say communicates, in between the hardware and various application, and the shell commands, that is called as kernel. The same line is written over here. Users communicate with the kernel through the program known as shell. Now in this subject, we are going to introduce our new technique, that is called as a technique of shell. Just remember right now the word called shell. It's just like a one prompt, or we can say C drive, D drive. We are supposed to speak all these words in routine for the Windows operating system. Someone says that just open my D drive, then what we will do? We'll click on my computer and then just select the D drive will get open, right? So that C and D and E, whatever are the drive letters. Actually, that is the allocated logical space inside the secondary storage device, which has been given as a specific label name. So the same label name is known as a shell in Linux operating system. I think all of you are clear. The shell is a command, or we can say the shell is a command line interpreter. It translates the command entered by the user and convert into the language which is understood by the kernel. See, this is the architecture where on outer layer there is a number of users are there. Then after that user there is a bunch of application program which can be distributed into the number of mail, FTP, DBMS, various application programs, so on. Then there is a layer of various Unix command. All these Unix command are identified by the one component which is called a shell. Whenever user requests anything, shell rectifies that particular request and find out a specific command from this list and pass it to the kernel, and this kernel converts into the binary language and it pass into the specific hardware. So this is the actual workflow of Unix architecture. Now let's discuss some history about the Unix. Unix was originally developed in 1969 by the group of AT&T, and the group of peoples like Ken Thompson, this is the very famous name in our field, Dennis Ritchie, the founder of programming in C, Douglas and Joe. Again, these are the very famous name in web development. All they are working in a single lab, that is a Bell Lab, where they have seated together and invented a one new operating system in the year 1969, that is Linux. Nowadays, there are various flavors of Linux are there into the market. I am just taking the name like Red Hat, Fedora, Puppy Linux, Ubuntu, etc. etc. But at the time of invention, that means in the year 1969, this Linux is actually known as a one programming language. That programming language is called as B programming language. Then by giving a lots many efforts by the Dennis Ritchie, it is known as a C language. And right now in BCA semester number 1, we have this C language as a one subject. Anyways, leave it. It's a history and we don't like the history. Now as you can see into this Unix architecture, as it contains various layers. So now it's time to discuss about all these layers in detail. So I think this was the sufficient dose for today's lecture. In our next lecture, we'll go for in detail discussion about all these layers, that is user layer first, then application layer, then the layer of various Unix command which is held by the shell, then we'll discuss about the kernel, and then lastly we'll discuss about the hardware. So thank you very much students for listening me, and have a nice day.